Hey everyone, I hope you are having a great day today here at DoK Days. I'm Hrittik, a community advocate at Portina, and with me is Ryan Gray, a technical consultant here at Portina. Join us on this exciting event titled Resilient Redis, where we are going to talk about why Redis is used and where is it used, data on Kubernetes, and why data on Kubernetes is important. How can you deploy Redis on Kubernetes? And by the end of the talk, we will help you with a checklist to deploy Redis on production on Kubernetes. Why Redis? This is one of the most important questions we are asked. So Redis, which stands for Remote Directory Server, is a fast open source in-memory key value data store and is used as a database, cache, message broker, and queue. The popular use cases of Redis in production are caching, queues, pub sub systems, gaming leaderboards, session stores, rich media streaming, and a lot more. It's highly available and scalable. Redis supports either a single node primary or a clustered primary replica architecture. This enables you to create highly available solutions with predictable performance and dependability. When you need to change the size of your cluster, it's as easy as to go and scale in or scale out. This allows your cluster to scale and meet your needs. Replication and persistence is another advantage of Redis. Redis uses a primary replica architecture that allows for asynchronous replication of data across multiple replica servers. This improves read performance since queries are distributed among the servers and allows for faster recovery when the primary server goes down. Redis also gets point-in-time backups for persistence by using disks. Another key benefit of Redis is performance. Redis is synchronous with performance and all Redis data is stored in memory, allowing for faster data access with low latency. In-memory data storage, unlike traditional database, do not require a trip to disk, decreasing engine latency to microseconds. As a result, in-memory data stores can handle orders of magnitude more operations and provide significantly faster response times. As a result, read and write operations take less than a millisecond on average, and millions of operations per second are supported. This is one of the advantages why Redis is used across GitHub and a lot more organizations to use, store, and manipulate logs. Another disadvantage of Redis is its flexible data structures. Redis supports a lot of data structures to meet all your needs. And the last and most important advantage is simplicity and ease to use. Redis is one of the most popular open source databases. It has a lot of open source clients for most of the programming languages. Redis is very simple to set up if you are setting it for production or just test purposes. The simplicity makes it so popular. Why data on Kubernetes? Why should you store data on Kubernetes? The question is why not? Kubernetes was distributed orchestrator was originally designed to run stateless workloads, but today it is increasing in popularity to run databases or other stateful workloads. Various enterprises utilize data on Kubernetes, and communities like DoK are empowering users as well as organizations to do the same. How to deploy Redis? So you can either deploy Redis using Redis operator or you can use Helm charts. Helm charts is one of the most popular options. What is Portina? Portina is a GUI for your Docker, Kubernetes, Swarms, and IoT. Today, Ryan will help us with the deployment of Redis via Bitnami's Redis Helm charts.
Portainer makes deploying Redis via Helm chart very simple. The first thing I want to do is create a namespace for Redis to live in. So I'm going to click on Add Namespace. I'm going to call this Redis. And for the sake of this demonstration, I'm going to turn off resource assignment, and I'm going to go ahead and click on Create Namespace. And now that we have our new Redis namespace, I'm going to click on Helm over on the left, and I'm going to search for Redis in our list of Helm charts. I want to deploy the Redis cluster Helm chart. I'm going to select the Redis namespace that we just created, and I'm going to call this application Redis. And then I am going to look at the custom values for this Helm chart, because before I install it, I want to set a specific node port to use for my installation. That'll be port 32,000. And now I can click on Install. And as soon as the Helm chart is done installing, we'll get a notification that it's been installed successfully. And now we just wait for our replicas to come up. And by clicking on this name right here, we can get more details about our deployment. And we can see now that all 6 of our replicas are running and Redis is ready for use. A few other considerations that we'd like to point out are Redis's persistence strategy, disabling transparent huge pages, and benchmarking. Redis itself provides several persistence options. There are 4 persistence strategies in Redis. The first is RDB, the Redis database, which performs snapshots of your entire data set at specified time intervals. The second, AOF, append-only file, logs every write operation that the server receives. So when the server starts up, the log is replayed and it rebuilds the entire data set. Another strategy is no persistence at all, in which case your Redis data will exist for as long as the server's running, and then it will cease to exist when the Redis server stops running. And lastly, the combination of using the Redis database and the append-only file. Using this strategy, Redis will behave in an append-only file manner, but along the way, it will also be taking point-in-time snapshots. Disabling transparent huge pages. After deploying Redis, you are likely to see the following warning, and you can follow the fix in this warning and make sure that it is configured to happen at the next boot of your server. And this can be automated using init containers. And finally, some benchmarking resources.
Thank you for attending our talk, and if you have any questions, feel free to tag us on Twitter.